Hello everyone. So today again we will continue with the sensing. Sensing is performed by using transducers. For an example, photo devices used to measure the intensity of light are considered as transducers. Transducer is defined as a basic element that converts one form of energy to another form, usually electrical energy. So that one form can be mechanical or any other form, but further it is converted into electrical energy with the help of transducer. The question is, why is it necessary to convert one form of energy to another form? And what are those forms? The immediate answer is very clear in the sense that the signal or energy in the current form in fact is not suitable for observation, measurement, quantification, or manipulation. Transducers are mainly used to quantify the physical, electrical, fluidic, and mechanical variables such as temperature, pressure, magnetic field, voltage, flow, vibration, radiation, and so on. Such parameters are commonly be called as measurements. Some of the important measurements are listed as follows. So you can go through this list. Many of the measurements you are already, or almost every measurement you have studied earlier. From the observation, measurement, quantification, or manipulation of measurements, different type of transducer with different transduction principle are used. For example, the transducer that is used for the detection of temperature is different from the transducer that is employed for the detection of ultrasonic sound signal. For various applications, a variety of transducer with different transduction principles are designed and fabricated. The term transducer and sensor have been used synonymously, although the concepts are little different in the macro level system design. Transducers are the physical element which is a part of sensor. Indeed, transducer is an essential element of a sensor. A sensor is merely a sophisticated transducer because it contains the signal conditioning circuits capable of amplifying and refining the weak and raw signal that is available at the output of the transducer. So just understand in simple terms that transducer is a device which converts one form of energy into another form, and mostly that another form is electrical energy, and the combination of transducer along with signal conditioning circuit is known as sensor. Some of the commonly used signal conditioning circuits are amplifiers, noise filter, offset compensator, and analog to digital converter. There can be many other, but here just for example purpose we have mentioned these signal conditioning circuits. The input signal refers to as measurement. The output of the transducer is referred to as equivalence. Signal or energy at the output of transducer and hence at the output of sensor is in different form with respect to the input signal or energy. Further, in this chapter, transducer and sensor will be synonymously used because in study of microsystems they are treated equally. So here a typical sensor showing transducer and signal conditioning unit is shown. So as discussed, the combination of transducer along with the electronic circuit for signal conditioning is known as sensor. Depending upon the application requirements, various type of mechanical microsensors are fabricated. Sensing is possible through micromechanical components adopting microactuation principle. At this stage, it is sufficient to say that some microactuators can also be used as microsensors in some applications. For example, when a micro cantilever tip, which is under deformation due to control by a signal, touches another element in a system, a kind of touch signal is said to be generated. Although micro cantilever beam is a kind of a actuator, micro actuator, but here because of the touch action, it is producing a touch signal and acting as a micro sensor also. In another example, the phenomenon of piezoelectricity and piezomechanics of piezoelectric material can be exploited to fabricate microactuators as well as microsensors. So in the upcoming lectures, we'll study in detail about the piezoelectric material and how, with the help of these material, piezoelectric and piezomechanics can be further discussed. So in the upcoming lecture, we'll discuss about the actuation process.